Hello, hello. Yes, we welcome you back to PSSB, Physical Sciences Laboratory. Now, today we are looking at this question. It comes from the electrical circuits. Okay. First question says, calculate resistance X. Okay. So when you look at, this is the resistance we are talking about. This is X. Okay, how do you find X? How do you determine X? This is what you have to know. We are having a voltmeter here, which reads 9 volts. And what do we note? We are having a 5 ohm resistor, and we are having these two. So now we have to know that from the principles of electricity, the 5 ohm resistor and these two, they are in parallel, and potential difference across parallel network is the same. So what are you going to say? The potential difference across 5 is 9. The potential difference across both this one is 9. It must be understood that it is not that the potential difference across 4 is 9 or potential difference across X is 9. I repeat, the potential difference across both this one is 9. And with that, we can come up with the formula. What does the formula say? It says V is equal to V1 plus V2. Our V is 9. What is V1? The V across 4, and V2, the V across X. But you have to recall that every V is equal to IR in accordance to Ohm's law. So what are you going to say here? You're going to say 9 is equal to IR4 plus IRX. Okay, it happens that in this circuit, we know the current through here is 1.2 ampere. So what are you going to say here? We are going to say 9 is equal to 1.2 times 4 plus 1.2 times X. And from there, we can find out what X is. So that is it. That is our X. It is 3.5 ohm. Next is another question. Then comes this question. It says, calculate the total external resistance of the circuit. Now when you look at our circuit, we have this one, it's one cluster. We can call this one resistance, and this one another resistance. So we have two clusters, and we are going to say R total is equal to R parallel plus R series. So R total is equal to R parallel. R series is known and is 6. So what do? We calculate R parallel. So you say 1 over Rp is equal to 1 over R1 plus 1 over R2. So 1 over Rp is equal to 1 over R1. R1 is 5 plus 1 over 7.5 that one will give you your RP. Okay, let's see what we can do. So we know now the parallel resistor as 3. What do? We substitute it in the equation, and we get total external resistance. So we're going to say RT is equal to RP, which is 3, plus RS, which is 6. You get 9 ohm. Okay. Then comes this question. It says, calculate the ammeter reading A. Okay. Now, if you look at our A is in the main body. So A reads I total. Okay. But you have to know that I total is made by a combination of this one and this one. Those are the only 2 branches we have. So when these 2 current flow, when they reach here, they combine. So we have the equation. What's the equation? I total is equal to I1. Let me call that one I1 plus I2. This one is I2. Okay. So I total, what is I1? I1 is calculatable. So we'll calculate it. But I2, we know it was given, it's 1.2. Okay. Then how do you get I1? You get your remember, you are looking for I1. You know the PD across, which is 9 volts. And the resistance, which is 5 ohm. Okay, those 2, what do? These 2, they serve to give you I1. So, in other words, V is equal to IR, where V is 9, I is wanted, and R is 5. What do we get? You get I1 equals to 9 over 5. What's the answer? Let's get it. So we get 1.8 as I1. So when you come and substitute for it, you're going to say I total is equal to 1.8 plus 1.2. Answer is 3.00. It's I ampere. Thank you. Let us look at the next question. Then comes this question. It says, when switch S was open, the voltmeter reading changed to 29.00 volts. The question says, calculate the internal resistance of the battery. Okay, how do we go about that? Okay, you have to remember that if we open this switch, what actually happens? What happens is that all this part of the circuit is off. But you have to remember that the voltmeter is still connected across the battery. And when the voltmeter is connected across the battery, we have to remember that the voltmeter has infinite resistance. So no current is flowing. And when there's no current flowing, the reading across the voltmeter is EMF. So EMF is 29.00 volts. Okay. What else do we know? We know total resistance of the circuit. We found it as 9 ohms. And we know I total, which was 3 ampere. So what do we do? Okay, we know that EMF is given by IR plus I internal resistance. So if EMF is 29 and I is 3 and the internal resistance and external resistance is 9 and the 3 times internal resistance, what you get out of that will be the internal resistance of the circuit. So what do? We have to rearrange and then press the calculator. Let us see what we get. Okay, with that, we are going to cut this video here. We are not going to get tired of thanking you for staying with us, and also to pray that you subscribe and you click that like button. See you next time. Bye bye.